one of the important helper tool to be used as part of the toolchain package is the object dump or ObjDump, or at least this is the name within the GCC toolchain. The object dump will help to get the disassembly representation out of the ELF or the object file. And when we are talking, for instance, about the disassembly representation, we are talking about the binary representation of the instruction itself. Here, of course, we'll have the hex format, but once we do the binaries of this hex, we'll get the binary representation of the instruction. Then the tool will do some kind of reverse engineering and get the instruction name and the operand used out of this binary representation. And here, if we are doing the disassembly of the ELF file, then we will get the absolute address of the instruction. What he is doing is just we have what is called the starting address or the entry address, and this is the start address of our binary, and based on the offset of each binary instruction within the binary file, then it will be able to determine the offset in comparison to this ultimate start address. And from there, it can, for instance, determine the absolute address for each instruction. In this example, the 8 million will be the start address, and here 210 is this offset for this instruction. Once you do the addition, that it will get the absolute address for this push instruction, and this is applicable for the rest of instructions. Now, when it's come to the label names, function names, and even section names, this is actually part of the metadata, whether it is part of the metadata of the ELF or the metadata of the object. Although the object most of the cases is just binary representation, but when we decide, for instance, to provide the debug information and some metadata, then the information about the function name or the label name as well as the section name will be part of the object. And out of it, actually, once we get the disassembly, we can get those names as part of the disassembly representation, as we can see here. The disassembly file is quite important actually, because it allows us to see each instruction where it is located, and this helps us, for instance, once we loaded the binary, to compare the content of the memory to the disassembly file and to know if really our binary is loaded to the target or not. So we can compare, for example, the content of this address to what we have to the disassembly and check really that our binary was loaded. This is one thing. Also, it helps us to spot error here. For instance, we can try to check, for instance, if we are loading some invalid values here, or if this sequence doesn't match what we are expecting in terms of functionality to the C level representation of our count, and many other spots. So really it's very important to have this file, and in many cases the generation of this file using the ObjDump tool is integrated as part of the build process.